I'm going to introduce two black plates. Again, they are thin. I'll make it this small. Okay, I think you are able to see complete question as well as the explanation what I'm going to put. Okay, these are the black sheets that were introduced. Temperature of this be T1, T2, and TA greater than TB. Same vacuum is there still. So what happens to the power flow between them? That's what the question that is asked. After some time, stationary conditions are obtained. By what factor eta is the stationary heat flow reduced due to the presence of heat shield? So what are heat shields? These are heat shields. Now it will be given black coating. I need not to show all. I think it's understood. How to manage this one now. So let's first write expression for P naught, looking at the first diagram. P naught is equal to, according to Stephen's law, sigma A temperature TA to the power of 4 minus sigma A TB to the power of 4. Since TA greater than TB, so what this surface, it will be, let A be the area of cross section. So what is capital A? Area of cross section of plates. Okay, no, let's get into the discussion now here. What is this equation, sir? We are not understanding. Okay, this surface is there. It will have emission as well as absorption. What is emission? Power emitted, sigma A, TA to the power of 4. What is absorption? Sigma A, TB to the power of 4. Same thing with this also. Since TA greater than TB, the emission will be greater than absorption. For your understanding, I'm just giving it in this way. So I think we used to indicate colors like this, no? Emission as well as absorption. You can show more lines for emission because TA greater than TB. I'll shade this. So this is the absorption and this is the emission. Agreed? PE, PA. This is Stephen's law. Okay, this is the initial part. This is for the initial before introducing sheets. What all this discussion before heat shields now after introduction of heat shields. After heat shields are introduced, what will happen to the power? Okay, I'm directly. So what happened? This shields also happen. They'll be at certain temperature. So what they do, they'll also the same situation. They'll be emitting. Okay, let me call this as P1, P1, and this will also emit PA. Even this will also emit. Show it all. Okay, there's emission. So now what this shield 1 will do? So it is emitting. What is the power emitted by it? P1, P1 and P1. It will absorb power. It will absorb the radiation emitted by the plate 2 and the plate A because this will be incident on it. Okay, let me not show green color or if you are interested, it has to be shown like this here. This green colors are what it's. The radiation emitted by this will be absorbed by this. The radiation emitted by this will be absorbed this. Since we had a practice of writing, no, this one. So here I'll bring it here. Let me change the problem little bit so that it'll be easy for you. Okay, agree this one now. So now what is it? They are in equilibrium. It's all. So in equilibrium, what will happen? It will be emitting from two surfaces. It's a plate, not a wire. Huh? It's a plate. They are each shell. It's a plate. And at the same time, it will be absorbing the radiation emitted by the plate A and plate 2. So at equilibrium, what we can write for plate 1, for each shield 1, after each shields are introduced, thermal equilibrium of each shield 1. No. Power. So what do you mean by that? Power emitted, total power emitted is equal to total power absorbed. What all it will emit? It will emit power 2P1, shall we write? And what all the power emitted by the sheet 2 and sheet A will be absorbed. Total power absorbed. So how much it is? Power emitted by the sheet A and the power emitted by the sheet 2. I think no need to write further explanation. Directly I'm writing equation. So what is PA? Why you are writing power absorbed? What all power emitted by sheet A will be incident on sheet 1? What all power emitted by sheet will be incident on sheet 1? Okay, let's write Stefan's law. So this one, what is P1? Sigma A T1 to the power of 4. They are black, no? Okay, I need not to go for emissivity. So sigma A TA to the power of 4, sigma A T2 to the power of 4. So this will be 2 T1 to the power of 4. Similarly, for thermal equilibrium of heat shield 2 will discuss. Just some observation, if you make it, you can crack such numericals. Only thing is, what is the biggest problem? You want to solve within 2 minutes. First time, not possible. First time when you are learning, no, you have to put effort, you have to analyze, you have to think. No, total power emitted by it. Again, it will be 2P2 is equal to P1 plus PB. What all it will emit power. Then what is the power absorbed? The power emitted by the sheet 1 and the sheet B is what will be incident on the sheet 2 and that will be absorbed. Okay, let's write sigma A T to the power of 4. Okay, this will be P1. P1 will be sigma A T1 to the power of 4, sigma A equation 1 and 2. Solving, we know TA and TB temperatures that are given. Okay, TLH, TA is, I think the symbols, I'll change it. We took it like this, no? TA. Okay, let me carry on with their symbols. Okay, I got this much here. But what is the question? Is asking after sometimes stationary conditions obtained, by what factor eta is the stationary heat flow reduced due to the presence of it? What do you mean by heat flow? What is the next part of the problem? I think the question is not yet over. So what was earlier? Earlier the flow was P0, no? Now what is the flow? PA minus P1 is the flow. Or P1 minus P2 or P2 minus PB. What will be that one? So I'll get into the discussion like this. So this is P now. So first I think we have to solve and we should get expression for the T1 and T2 in terms of what? If I can get T1 also, no problem. Anybody T1? Solving 192. T1 and T2. Okay, T1 will be T2TA to the power of 4 plus TB to the power of 4 by 3. Okay, let it be after solving 192. I'll end up this one. So call equation 3. Okay, now I know T1 and I know TA. So what is the resultant power that is flowing between the sheet A and the shield? Or see, there's nothing wrong. Please do think like this. Huh? Because as a student, you feel different powers is flowing. The same uniform power will flow. Okay, what is P? You can write PA minus P1. So do we know PA? Yes. Do we know P1? This is the next part of the problem. Okay, PA will be sigma A sigma A T1 to the power of 4. Solving this, we'll get expression for P. I do remember it's a very famous problem, no? Yeah. Okay, what was earlier P naught? Sigma A TA TB4. So let me compare P and P naught. So TA to the power sigma A TA to the power of 4 minus sigma A TB to the power of 4. What can be replaced here? Okay, this let me call equation 5. 4. Okay, let me call this equation X. So put 4 in X. Put X in 4. So therefore, how much will get? P naught by 3. So he's telling it will in fact reduce by eta times. So what is eta? 3. This is our answer. Just based on Stephen's law, questions will be like this. Huh? Both the surface, y2 is something very important, y2. Both the surface. Sir, why not here? Yes, it will be radiating, but since we are interested the radiation that is flowing towards right for the plate A and the radiation for the plate B that is moving towards left. In fact, we'll give also this one. We are not bothered that part, no? This power P naught is what I should write here. This radiation minus this radiation. I'll scroll down. One more good problem is there. Yeah. It's based on Newton's laws of cooling.